Now we're going to be studying carbon nucleophiles. And in this sense, we're going to be doing, for example, Grignard. We're going to be doing cyanide. And we'll also be doing Wittig, the elide as nucleophile. So phosphorus, this is 3 phenyl groups. And that's positive. And say that we have this. All right. Oh, and that doesn't have a double bond, just that negative charge. All right. So what do we have here is carbon nucleophile, which are very strong nucleophiles, strong base, strong nucleophile. Here, this is polarized in this direction, so pretty much acting as an ion. Here, negative charge. Remember that our goal when we're studying functional group is analyzing how can we prepare them, how they react to predict products or find the reagents if we're given the final products, and how can we use that knowledge to plan synthesis, interconverting functional groups. So let's go with the Grignard. And now let's start with a ketone that is symmetrical. And here we're going to do a little bit about parallel with the hydrides. So this one, this is cyclohexanone. And if I make this react with metal, magnesium, bromide, that's a Grignard, right? And that'll be dry ether, right? The conditions. Dry ether or diethyl ether or EHF. Anyways, your nucleophile is a carbon, very strong nucleophile and base. So steps are when you have such a strong nucleophile, the hydrides or this carbon nucleophile is always nucleophilic attack first. So we're going to go over and do this nucleophilic attack. And now, in doing so, what is very important and say interesting in synthesis is that Grignard reaction is one of the strategies that we use to make new carbon-carbon bonds. Notice that this is another carbon. So we have created a new carbon-carbon bond, and all of these reagents will do that. So now, after protonation, if we add water here, you will form an alcohol. What type of alcohol? If you have a metal here and an OH, that is a tertiary alcohol. So always from a ketone, you get a tertiary alcohol. I'm going to do an aldehyde now. Say that I have, this is 1, 2, 3, propanol. Propanol. And same, say that I use metal magnesium bromide. And I'm going to do plus, and that is a metal negative, right? So we're going to do nucleophilic attack. Again, it's a strong nucleophile. It goes by that mechanism. So nucleophilic attack directly over to that carbonyl carbon. We're going to have O negative here. I'm going to have my H, and I just added a metal. So that's new, a new carbon-carbon bond. That's one here and this one here. So very useful to add carbon atoms to the chain. After you protonate, we started with an aldehyde, remember. After you protonate this, you're going to end up with the following. So ethyl, metal, you don't draw the H. So that's a secondary alcohol. So analyzing how many products are we forming? Here, you're not forming a chiral center, right? Even though, yes, that's trigonal planar, that center, but at the end, you have this chain is identical to that, so not chiral. So you have one product. Now, what happens here? From the aldehyde, this is an H and an ethyl group. That's unsymmetrical, that carbonyl. So you are creating a chiral center here. And I'm going to do wedge here. So you can do that. The attack on either side of the plane. So you will get that plus the enantiomer. So when you're predicting products, you need to draw that. You can determine the configuration here is going to be priority 1, 2, and 3. Number 4 is the H that we didn't draw at the beginning. So it's going to be S. that configuration, and you have the enantiomer. So, but what I want you to see is the contrast between Grignard reactions and the what happens, what would you get if you use the hydrides? So, because hydrides are similar in the sense that they are very strong nucleophiles, the attack is direct. But if I use, for example, this same molecule that I had above, so cyclohexanone, and I do lithium aluminum hydride, I'm going to be adding an H here. So in that case, I'm going to form the following. And this time I'm going to specifically draw the H. So step 1, in step 2, you add the water and you're going to form an alcohol. So ketone, you have a secondary alcohol. And again, that's not chiral, even though that trigonal planar is not, that side is identical to that. So in that sense, looks the same. Here, remember that in the case of Grignard, if the group that you're installing metal is different from that, you're creating a chiral center, so you get a racemic mix. But what if I do the same aldehyde with now a different nucleophile? Instead of a Grignard, say that I'm using now lithium aluminum hydride. In that case, I'll be adding another H. So if you add another H, you're going to have OH, H, and H. That is a primary alcohol and is no longer chiral. So you see, it is important that we understand the geometry, so that's trigonal planar. And whether or not we are creating a chiral center whenever we do these molecules.